All right, half-angle theorems, day 2. Here we go. I'm going to see if this video goes a little bit better, maybe a little less jumpy. What we're going to do is more half angles, but we're going to apply some of the stuff that we've been doing in previous chapters. So that we've done this stuff before, it's just going to look slightly different. So I've got this example. I want to figure out what sine of theta over 2 is. I don't care what theta is. I don't care what this angle is. I don't care what theta over 2 is. All I want to know is what sine of theta over 2 is. So I've just copied that off of my identity sheet right there. The first thing I want to answer for myself is that positive or negative question. And for positive or negative question, I got to say, okay, well, where is theta over 2? And the thing is, they almost told me where it is. You see this right here? They almost told us. They told me where theta is, but I don't care where theta is. I want to know where theta over 2 is. What am I going to do? Well, I just need to just aha! Well, you can't do that. You got to do it to everybody. So you got to divide all of these things by 2. So you've got a pi over 2, and I'm just going to kind of make a little graph off to the side here. So theta over 2, that's going to be right here, and then 3 pi over 2 over 2. So that's 3 pi over 2 times 1/2. So that's 3 pi over 4, right? 3 pi over 4. 3 pi over 4 is right here. So we know that our angle is somewhere in here. And if we think about that, all students take calculus stuff, that stuff still works. We're just not using the whole quadrant. But so what? We can just pretend we were using the whole quadrant. So we are going to say that this thing should be positive because this little red chunk is in the quadrant where sine is positive. So I want to go over to this thing and I want to get rid of that little negative, and I just want to use the positive case. Now cosine, we still got to figure out what that is. Now that is something we've more traditionally done. In fact, I'm just going to jump to the cosine. So I've got my angle in. Notice that I also added in those negatives since it's going to the left and down. There's a negative value for both of those. Now cosine is the thing that I still have to figure out. To find it, I need to do what cosine is. Cosine is adjacent over the hypotenuse. We have our adjacent side right here, but we don't have the hypotenuse. So use the Pythagorean theorem. 12 squared plus 5 squared is 169. Hey, this turns out to be 13. I just did the Pythagorean theorem in my head. That's all I'm doing there. So cosine of whatever this angle happens to be, and notice I'm using the actual angle and not theta over 2, is going to be that adjacent, so negative 12 over 13. So we want to plug that into our formula. And now we've got cosine just plugged in there. And now I just want to simplify that. So to simplify it, I'm going to multiply top and bottom by 13, get rid of that fraction inside of this radical. So I've got 1, I'm not going to write the plus anymore, plus 12, right? Yeah, 1 plus 12. Oh, no, 13 plus 12, excuse me. Forgot to distribute. Over 26. And this is all still getting square rooted. So we get the square root of 25 in the numerator, so that's 5, over the square root of 26. I'm going to simplify that radical. 26 doesn't have any perfect square factors. No. But I do want to get that radical out of the denominator, so I'll multiply top and bottom by the square root is 26. So we get 5 square roots of 26 over 26. And that's the value of sine of theta over 2 if we were given that tangent value. Let's do another one. We're going to do 2 more. It says your turn. It doesn't. It's not your turn. Don't look at it. Don't look at it. Once again, we're trying to find sine half angle. This time we were given cosine, which will be great because we need cosine anyway. Oh, this one's going to be even easier. So I still have to do that positive or negative stuff. So I'm going to start out with that. They gave me theta up here. You can see that, but I want to need to know where theta over 2 is. That'll tell me if I want the positive or negative case. So I want to divide all of these by 2. So 3 pi over 2, if we cut that in half, we're multiplying by a half. So we get 3 pi over 4 is less than theta over 2, which is less than pi. Okay, so theta over 2 is somewhere in there. So if I made my little graph real quick, and I'm only going to have to make this one, I think. So here's 3 pi over 4. And then here is pi. So our theta over 2 is chilling in there, which is another place where sine is positive. So again, we're not going to use the negative case. We're going to use the positive case for this thing. Now, these idiots, they kind of made it easy on us. Hey, this 3/5, just slap it right there. They told us what cosine of theta was, so just slap it right in. If we needed like tangent, we would do that other stuff. But they gave us cosine. Just plug it in. So I'm going to ignore the positive because we don't really need that anymore. So we get the square root of 1 minus 3/5 from up here, the 3/5. And I pointed with my pointer thing, so I don't think you actually saw that. So this 3/5 up there, and that's over 2. Now it's just a matter of simplification. We're going to multiply by 5. We get 5 minus 3 over 10, and it's all square rooted. 5 minus 3 is 2. So we get the square root of 2 over the square root of 10. We need to simplify this radical, so we get the square root of 20 over 10. What I was doing there is I multiplied the top and bottom by the square root of 10 in order to get rid of the radical in the denominator. But in doing that, now that square root of 20 can be simplified. That's a square root of 4 and a square root of 5. See how these kind of like just seem to not stop simplifying? Square root of 4 is 2. 2/10 is the same as 1/5. So we get 1/5. So really, there's just a 5 on the bottom and a square root of 5. You could write 1 square root of 5, but I think that would look a little goofy. But that's our answer. Square root of 5 over 5. Done. Last one that I'm going to do in the video. We're going to do a tangent one. And quick reminder of our half angle options. The other two, if we got sine or cosine, we don't really have a choice. With tangent, we do have a choice. So I got cosine, and I can choose any one of these. Now, this you might be tempted to use it. Don't use one of these ones. If you do this one, you're going to have a bad time. You're going to have to do more simplifying because think about like we got to get that square root out of the denominator. No, it's not going to be very easy. So avoid that. Use this one. It's much easier to get the square root out of the denominator. So that's why I picked that one. But plus side, we don't have to worry about deciding positive or negative for tangent half angles because there's no plus or minus in the front. I do need to figure out what sine is. They gave me cosine. I got to figure out what sine. Here we go. So it is in the fourth quadrant. I can tell because 3 pi over 2 is down here. And then our 2 pi is over there. I don't really care where half angle is because I don't have to worry about that for tangent. So I'm going to draw my angle. Whoop. Cosine is adjacent over hypotenuse. So I know this thing is 3 and I know that is 5. And hey, that's a 3, 4, 5 Pythagorean triple. That's one of our cool Pythagorean triples, 3, 4, 5. You can just use the Pythagorean theorem otherwise to find that missing side. That 4 is going down though. I'm yelling timber. That thing's got to be negative. So if it's going down. Then use that for sine of theta. Sine is opposite over hypotenuse, so negative 4 over 5. We'll plug both of those in. I'm just going to jump to that. So there I plugged in the 3/5 that they were giving me originally, and my negative 4/5. Now I just need to simplify this thing down. So I'm going to multiply the top and bottom by 5. Ooh, that's going to get rid of both of my fractions. Oh, you so nice. 1 times 5, that's 5 minus 3. Negative 4/5 times 5, that's negative 4. So we get 2 over negative 4. Oh my gosh, this is so easy. I'm so glad we picked the easy one. So we get negative 1/2 as our final answer. That ends today's video thing. Keep in mind when you're doing these things that you care about where half theta is, not where theta is, and that you make these little drawings. These little drawings help you out, like this one where you need to find sine or cosine, as well as these ones where you're trying to determine what quadrant what quadrant theta over 2 is in, so that you can decide positive or negative for sine and cosine. You want to go to the practice now to see how well you understood everything in this video, and I will see you after that.